Okay, grade nines. Let's today go through let's do those three examples that I wanted you to try on your own. I'm going to go through them with you today. They were the ones that we didn't do in the last lesson because we just did some other examples to kind of give us a better introduction into the idea. So today we're just going to do those three examples that are actually in the booklets. The first one is talking about, the number of DVDs rented. That sounds familiar. So we'll just jump right into it. The table of values shows the cost of renting DVDs at an online store. So first off, we have to graph the data. And does it make sense to join the points on the graph? That's our main question. And then we have to talk about whether the relation is linear. Remember, that just means that it's a straight line on the graph. And then use the table to describe the pattern in the rental cost. We'll get to that part. So the first thing we have to do is graph the data. So we look at this, and we look at these two values, and we have to look at which one is going to be on our x-axis and which one is going to be on our y-axis. Remember, the x-axis is the independent variable, and then the y-axis is the dependent variable. So it would make sense then that it depends how much it's going to cost based on how many DVDs I rent, right? So we'll make the x-axis the independent variable. I've got 5, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 spots to fit 5. Let's just go with, we might be 1 off, but we'll go with every 2. So, oh no, yeah, we'll just do every 2. We can't fit every 3. So we'll go 1 is here, 2 is here, 3 is here, 4 is here, 5 is here. And then we have to get up to 1750. So we'll just do 1 for every one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we'll go 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, now our job is to just plot the points. So when I am at 1, I am at 350 on the x-axis. Let's also do this, or sorry, on the y-axis. Let's also do this. Number of DVDs. And this one here is the cost in dollars. Okay, so when I'm at 1 DVD, it costs me 350. So I go 1, 2, 3, and it's going to be kind of halfway in between. So right there. And then when it's 2, it's $7. So 2, I go up to in between 6 and 8, 7. And then 3 is 10.50. So 3 up to 10, in between 10 and 11, right there. 4 is 14. So 4 all the way up to 14. And then 5 all the way up to in between 18 and 17, 17.50, like that. There we go. We've graphed the data successfully. That's part A. Does it make sense to join the points? Well, we can't buy 1.5 DVDs, right? I can't end up right here anywhere. So I really can't end up at any of these points in between here. I can't be there because it doesn't make sense to get half of a DVD. So, no. The points are discrete. Explain. We'll say you can't buy 1/2 of a DVD. Okay. B. Is the relation linear? Yes. A straight line. The points lie in a straight line. So the relation is linear. The points form a straight line. So the relation is, oh, that's not how you spell that, linear. Okay. And then finally, C, use the table to describe the pattern in rental costs. How is this pattern shown in the graph? This is really just as simple as saying, as the number of DVDs rented increases by 1, as we rent one more DVD, a rental cost increases by $3.50. So each point on the graph that I move to the right by 1, I move up by $3.50. So the pattern is a straight line, but we'll say how use the table to describe the pattern. Let's say every extra DVD rented costs an extra $3.50. Pretty easy. Okay. Let's move on. Example number 2. Write an equation. Oh, no, this is example number 3. We don't want to be there yet. Number 2. So we're going to do this equation, 6 minus 3x. So part A says create a table of values for the relation. So this is going to look something like this. And we're going to have an x and a y. And this graph actually isn't really set up very well for this because it says create a table of values for the relation from the values of x equals -3 to x equals +3. So we're going to go -3, -2, -1, 0, 1, 2, and 3. So all you have to do to find the y value is you just need to plug the x value into here. So I'll give you a couple examples here just right off the bat. So it would be 6 minus 3 times -3 for this one, right? What's 6 minus 3 times -3? Well, 3 times your bed math, right? 3 times -3 is -9. 6 minus -9 is the same as 6 plus 9, which is 15. So then this one now, this next one would be 6 minus 3 times -2. And then this one would be 6 minus 3 times -1. And then 6 minus 3 times 0. 6 minus 3 times 1. 6 minus 3 times 2. And 6 minus 3 times. We'll do them all. 6 minus 3 times -2. That is going to give us 12. 3 times -2 is -6. 6 minus -6. 6 plus 6. 12. 6 plus 3 basically is what this is going to give us is 9. And now we start to see a pattern. 15, 12, 9, 6 minus 3 times 0. Well, that's just 6, right? Because 3 times 0 is 0. And now we're noticing 6 minus 3, 6 minus 6, and then 6 minus 9. So there you go. There is our relation. Now I need to do a slight alteration to our graph here because it is going to be in the negative x, right? We're starting from x equals -3. So I actually need my y-axis to be in the middle because I need to go 1, 2, 3 to the left, and I need to go 1, 2, 3 to the right. And it's actually going to go below in the -3 right at the end, but we'll just draw it down there. That's fine. So okay, now we plot. Right now it says create a table, so that was our first part. So that was A. That's good. We're done that. Now we need to plot. So it goes all the way up to 15. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we'll do it by 2 again. 2, 4, 6, 8, 10, 12, 14, and we'll go up to 16. Okay, so at -3, I'm at 15. At -2, I'm at 12. At -1, I'm at 9. At 0, I'm at 6. At 1, I'm at 3. At 2, I'm at 0. And then at 3, I'm actually at -3. So it'd be 1, 2, I don't know, something like that. -3, maybe down here. I made it a little bit too far down. It doesn't follow that perfectly straight line, but it's close enough. So there we go. We've graphed the relation. Does it make sense to join the points on the graph? In this case, yes, because you can have numbers in between here, right? I could plug in like a negative 2.5, and that would give me some sort of number in between those two, right? So in this case, you actually can connect these numbers. You can connect the numbers. I don't know what's okay. So that's part B. B is kind of this. And let's just specify that this is the Y and this is the X. Now let's move on to part C. What patterns are in the graph? In the graph, it's the same kind of thing. When X increases by 1, Y decreases by 3. And then is the relation linear? Again, it is a straight line. Therefore, yes, it is linear. And that's the second time in a row that I've started off spelling linear wrong. It's not a hard word to spell. Linear. Okay, that's example 2. We're flying through these. Let's move on to example 3. This one, again, the graph is not set up in a super ideal way, but that's okay. So example number 3 is the student council is planning to hold a dance. The profit in dollars is 4 times the number of students who attend minus 200 no matter what for the cost of the music. So we're always going to lose $200 for the cost. Okay. Write an equation that relates the profit, the number of students who attend. Okay. Seems maybe kind of tricky at first, but it's really actually pretty straightforward. So we need to relate the profit, we'll call it P, to the number of students who attend. I don't know, we'll call them attendees. It's kind of a lame word, but whatever. Okay, attendees. Now, what it said is the profit in dollars is 4 times the number of students. So if we forgot about the $200, P would be equal to 4 times the number of students, but it's always minus $200 for the cost of the music. That's it. There is your equation right there. So sometimes these equations come together really, really simple, really, really straightforward because they just make total sense, right? Sometimes they're a little bit trickier to see. All right, B. B is create a table of values for this relation. And it doesn't say a number to like go from a range in. So for N and P, we can choose what we want to do. Maybe let's go from, I mean, we should consider a scenario where there's no students, 0. Then let's consider a scenario where there's 50 students. And let's consider a scenario where there's 100 students. And then let's just do one more. Let's consider a scenario where there's 150 students. Okay. So if there was 0 students, that would mean that N is 0. That would mean 4 times 0 minus 200. So that means that if no students show up, the profit is going to be negative 200 because no matter what, they're paying for that music. If 50 students show up, that's 4 times 50 is 200. So it's $200 minus the 200 for the music. So they just break even, 0. If 100 show up, 4 times 100 is 400 minus 200 gives us a profit of $200, which is pretty nice. And then if we have 150 students show up, we're actually going to be making a decent amount of money then, right? I mean, obviously now we can see that as we get more money, sorry, more students there, that makes total sense. It should be more profitable. 4 times 150 is going to give us 600, minus 200 will be 400 in profit. Now, graph the data that you put into your table. So that's part C. So again, same type of thing where our independent variable is going to be the number of students that show up, and then it depends how many students show up, how much profit we're going to make. So this right here is going to be profit in, yeah, we're doing it in dollars. And then the N is number of students or attendees, we call them attendees. Okay, this is going to be another one of those scenarios where I need to just get rid of this one because I do have a negative number on my y-axis. I go down to negative 200. So we'll put it somewhere here. Okay. So we go from negative 200 to positive 400. So let's go 1, 2, 3. Let's go with the 4 here. Negative 200. And then 1, 2, 3, 4. That's 200. And then another 1, 2, 3, 4. That's 400. And then we've got 0, obviously. And then we're going all the way up to 150. Let's go every 5. 1, 2, 3, 4, 5. That's 50. 1, 2, 3, 4, 5. That's 100. 1, 2, 3, 4, 5. That's 150. Okay. And now we plot. So we've got an n number of 0 gives us a negative 200. A 50 gives us 0. And then 100 gives us $200, and 150 gives us $400. Graph the data on the table. We did that. Does it make sense to join the plots? Does it make sense? What do we think? Some values are permitted in between those plots, but other ones could not be. There could be 82 point, right? There could be 82 students, there could be 83 students, could be 84 students, but there couldn't be 82.5 students, right? So the points technically shouldn't be joined because technically we actually have values in here that aren't allowed. Even though there's a bunch of values in there that aren't allowed, not everyone is allowed. So points not joined. Okay, because some values aren't permitted. We'll say that because some values not permitted. Okay, that was part C. So now we have part D, which is just a little bit of a logical last question for us to try to figure out. How many students have to attend for us to make a profit? So obviously anything above 0 means that we have a profit, right? Anything up here means that we're making a profit. Exactly 50 doesn't mean we're making a profit. If we make 50, we end up at $0. A profit just means that we're making money. So our p-value has to be greater than 0. So if p, let's say if p is greater than 0, then there is a profit. What is the smallest value of n that we could have that would make p greater than 0? We know that 50 ends up at 0. What's the next biggest that we could make? 51, right? So n has to be equal to or greater than 51 for a profit. Let's say that. For a profit to be attained. Okay, so there you have it. There are 3 examples that I wanted you to at least give a shot on your own, and then I said I would go through them with you. So I hope that helped if you had any parts that you were maybe a little bit confused about. I will post some Rebus puzzles right away, and besides that, have a great weekend. I will talk to you guys on Monday.